All right, this video is going to go over absolute value parent functions and absolute value transformations. So let's go ahead and get started. First thing you need to know is what the absolute value parent function looks like. It's absolute value has these bars, vertical bars, and basically they turn any value positive. So the resulting graph looks something like this. It's like it takes a V shape, and this orange dot is called your vertex. You'll hear me reference it a lot in this video. And then I'll also reference these green dots, the nearest points next to your vertex. So just keep in mind, by default, from that orange dot to the green dot, it's like up 1 over 1. So keep that in mind. That will change. You'll see. The domain of an absolute value function is all real numbers. And the range is everything from 0 to positive infinity. And the 0 has a bracket because it actually hits it. That's where the orange dot is. Because if you think about it, if you inputted 0, it would output 0. So absolute value functions can touch the x-axis. Now, if you shift them, they can kind of go wherever they want. So like, we'll look at a couple shifts next. This first one, that -5 is a vertical shift down 5. So I'm going to have a theme for all of these problems, and that's going to be to find your vertex first, your HK. So in this one, there's no horizontal shift. It's like it said x plus 0 minus 5. That's the same equation basically. So to find your HK, your vertex, go and look at your shifts. So like this one and this one. So my horizontal did not shift at all. So my x value remains the same. And then my y value went down 5, so -5. And I'm referring to, it went down 5 from the parent function where that orange dot is to begin with. So 0, -5 right here is my vertex. Now, in this example, they did not stretch or compress this function at all. So it's still going to take a 1-to-1 kind of slope to the next dot on the line. So it resembles the parent function in that regard. All you got to do now is just go connect the dots. Like that. So the domain of this is all real numbers. And the range of this, if you shifted down 5, now it's -5 to positive infinity. Like that. Okay, this next one, I have a +4 inside those bars, and then outside it's like a +0. So this right here is my HK, but the x's lie to you. So it's really -4, 0. This is my vertex. Now, from that vertex, I didn't stretch or compress this thing at all. There's no transformations there. So my green dots, the next dots on this line, are just 1-to-1 away, up 1 over 1, either direction. Then I just go and I connect the dots. Like that. The description, it was just a horizontal shift, left 4. The domain is all real numbers. The range is everything from 0 to positive infinity because we didn't shift vertically at all. We just shifted left 4. All right. To be honest with you, though, you're probably not going to see something like this because that one's too easy. You might see something more resembling this, where it has 2 shifts instead of just 1. So kind of approach it the same way. Go find your HK, your vertex. So that's at here and here. Remember, your x's are lying to you, so it's actually -2, -3. Go put a dot there. Now, we didn't stretch or compress or do anything weird to this one, so it still just takes a 1-to-1. So like It's 1-to-1 away from it here, just like this. And that would be my function. The description, this was a horizontal shift left 2, and then also a vertical shift down 3. The domain's all reals. And the range is going to be everything from -3 to positive infinity, like that. Okay, this next one, go get your HK. That's at 1, 4. Remember, these x's are lying to you, so it's actually a +1, a positive 1. So go put a dot at 1, 4. Now again, this does not stretch or compress, so my next dots are going to be up 1 over 1, either direction. Then just go and connect the dots. Like that. So the description, we had a horizontal shift right 1 and a vertical shift up 4. The domain's all reals. And the range, this one went from 4 to positive infinity. Okay, next one is where it starts to get a little more challenging, because you're going to stretch and compress these things, which is going to change. If you look back to the parent function, it's going to change where these green dots would go, where your next points would go. So here we go. First thing, go find your HK. So there's not a horizontal shift, so it's just 0, comma, and then a vertical shift down 2, so -2. Go put a dot there. All right. Now, here's what you kind of have to do. You have to identify A and identify B. So A would be 3. B is, there's a little 1 right in front of this X. So it's like 3 over 1. Put A over B, 3 over 1. That's the slope from this orange dot. So what I mean by that is, from this orange dot, rise 1, 2, 3, run 1 either direction. That's where your next dots are going to be. It's like A over B kind of thing. I don't like using the term A and B because it's weird. At B, there's some people call it B, some people call it 1 over B. Basically, because if there's a number in the B spot, it's lying to you. And so me saying A over B is not necessarily correct. I'm just showing you how I do this, okay? I put A over B, and it's the slope from that orange dot. And as I go through more examples, it might make more sense. We'll see how you do. Okay, this next one, go identify your vertex. -1, comma 0. Put a dot there. Okay, identify your A, which is 2. Put it over your B, which is, there's a 1 in front of this X, so 2 over 1. That's the slope from this orange dot. So rise 2, run 1 either direction, then just go and connect the dots. Like that. I just realized I didn't answer description, domain, or range of the first one either on this, so we'll just answer them all right now. I'm on number 5. The description, we had a vertical stretch times 3. We had a vertical shift down 2. The domain was all reals. And the range is everything from -2 to positive infinity. The second one, the description, we had a vertical stretch times 2. And we had a horizontal shift left 1. The domain was all reals. The range was everything from 0 to positive infinity. Okay. Those in my mind are considered the easier ones to do. Now we're going to look at some more difficult ones, like these down here. So buckle up and just try to kind of understand what I'm trying to get you to see here in terms of A and B. Okay. If I was approaching number 7, first thing I would do is I would find my vertex. That's at 2, 4. Let me move that back up. I don't know why it moved. Okay, that's better. 2, 4. Put a dot there. Okay, now find your A, which is a third. Put it over your B, which is 1. A third over 1 is just a third. This is your slope from that orange dot. Rise 1, run 3. So I'm going to rise 1, I'm going to run 3, I'm going to put a green dot there. And then I'm just going to go and I'm going to connect those dots. So it looks something like this. The description, this was a vertical compress times a third. Then I also had a horizontal shift, right 2. And I had a vertical shift up 4. I had a domain of all real numbers. Whoa. And then I had a range of, it goes from 4 to positive infinity. Like that. Okay, next one. Find your HK, your vertex, -3, 0. Put a dot there. Okay, now in terms of A over B, A is a half over B is 1. 1/2 over 1 is just a half. This is your slope to the next point. So rise 1, run 2. Put a dot there, either direction. Now just go and connect the dots. It looks something like that. The description, this was a vertical compress as well, times a half. Then you also had a horizontal shift, left 3. Domain was all reals. The range is everything from 0 to positive infinity, like that. Okay, on this third one, first of all, go find your HK. 1, 2. Put a dot there. Okay. Now all we got to do is figure out our slope to the next dot. Basically, it works like this. There's an A out in front. It's a 1. It's hiding. You can't see it. Now, when you do your A over B, technically B is just this bottom number. But the way I kind of do it is I just take whatever's here, because it's not always going to be a 1 on top. I just take whatever's there and I flip it. Flip that fraction. If you flip 1/3, it becomes 3 over 1. So I'm going to have, this is my B value. My A value is 1. So when I do A over B, it's going to be that 1 over B is 3. I know it kind of just seems like we did a circle just to get back to the same number that we started with. Yeah, sometimes it just works out like that. So this one, from this orange dot, I would rise 1, run 3 because of that 1/3 slope. Then I would go and I would connect those dots. And it would look something like this. All right, so the description, that 1/3, B was actually 3. That means that 1/3 sitting there is actually a horizontal stretch. times 3 over 1. The minus 1's a horizontal shift, right 1. Then you had a vertical shift, up 2. The domain of this function is all reals. The range is everything from 2 to positive infinity. And that would be it. Okay, let's see all this again. First of all, find your vertex. -3, 0. Put a dot there. Okay. The slope from this orange dot is A, which is 1, over B, which you have to take that 1/2 and flip it. That's my B, 2 over 1, or just 2. So when you do A over B, it's really like 1 over 2. This is my slope from that orange dot. Rise 1, run 2. Now go connect the dots. Like that. The description, this 1/2 here, well, B is actually 2. It means it's a horizontal stretch. Times 2. Then there's a horizontal shift. Left 3. Domain was all reals. Range is 0 to infinity. And that would be that problem. Okay, this last page is where it's going to get, I don't know, reflections aren't that bad. You just, instead going up, you go down. It's these horizontal compressions that are going to be kind of tricky for you. So here we go. First of all, find your HK. -2, -4. All right. A is 1. There's a 1 hiding out here. B is whatever's here flipped. So 3 flipped, put it 3 over 1, then flip it. Now it makes more sense. So when you do, this is my B. So when you do A over B, it's really like 1 over 1/3, which is really like 1 over 1 over 1/3, which is really like 1 over 1 times 3 over 1, which is really just 3, or 3 over 1. I know that part was confusing. Well, this is all just basic algebra, guys. So you can't get mad at me for confusing you there. You should be able to solve a problem like that. To be honest with you, if you're watching this video, you're probably advanced mathematically enough to solve a problem like that, or you should be. So when you do your A over B, just kind of make them both fractions. Then take the bottom fraction and flip it, and it becomes a multiply. That's how I get this value. So from my orange dot, which is at -2, -4, right here, I found out that my A over B was 3 over 1. So rise 3, run 1, either direction. Now just go and connect the dots. Like that. So the description, we found out B was actually 1/3 because you had to flip whatever was here. So it being 1/3 means it's a horizontal compress times 1/3. Okay, then you also had a horizontal shift, left 2. And you also had a vertical shift, down 4. The domain was all reals. And I don't know why range isn't here. We'll go ahead and answer it. The range of this is everything from -4 to positive infinity. All right, number 12. So let's see another example of a horizontal compression. Number 12, go find your HK, your vertex. It's 0, 1. Go put a dot there. All right, now identify A and B. A is out front, it's hiding, it's a 1. B, you're supposed to take this number. If it's 2, make it 2 over 1, because you're going to have to flip it, and it becomes 1/2. That's my B value. So when you do A over B, that's 1 over 1/2. Well, that's really like 1 over 1 over 1/2. And you can switch this to a multiply, like 1 over 1 times, as long as you flip this bottom fraction, 2 over 1. So you end up getting 2 over 1, or just 2. So my A over B, this was A over B. My A over B is 2 over 1. That means I'm going to rise 2, run 1, either direction. And honestly, if you're sitting here really struggling understanding that A over B kind of thing to the next point, I want you to kind of realize, first of all, horizontal stretches and compressions are not a teacher's go-to. We like the vertical ones more so. And secondly, these equations are input-output machines all day long. So what I mean by that is I could have input an x value of 1 into this equation, done a little bit of algebra, and it would have given me a y value of 3. That's a coordinate, 1, 3, right there, that green circle. These are input-output machines. So if you get stuck, maybe just input an x value and figure out what your y value is and kind of just play it that way. So for the description, this was a horizontal compress because remember, B was 2 flipped, which ended up being 1/2. So that's a compression. Horizontal compress times 1/2. Then I also had a vertical shift up 1. The domain's all reals. And I'm going to go ahead and do the range again for this one. The range is from 1 to positive infinity. Okay, last two, reflections. Reflections happen if you see a negative, and generally it's going to be before that letter X, unless they're really trying to trick you. So if you see a negative outside, that's a reflection across the x-axis. And if you see a negative inside, it's a reflection across the y-axis. All right, I would approach these problems the exact same way. So go find your vertex. This one's at -2, 3. Put a dot there. Now, you can basically kind of just realize that instead of going up, it's just going to go down on these. So like what I mean by that is your parent function went like that. Well, now it's just going to, once you reflect it, it's just going to go like this if you reflect across the x-axis. So I would follow a 1-to-1 slope, but in this case, instead of rising, you're falling to get to these next dots. I guess I should keep them in green. And if you wanted to use the A over B like I was talking about, imagine there's a 1 here and a 1 here. This kind of takes the shape of a -1 over 1 slope. So fall 1, run 1. But anyways, basically it just goes down like this. So the domain's still going to be all reals, but the range will change. Now instead of going from like something to positive infinity, it's going to be coming from negative infinity to the y value of 3, like that. Okay, and then this last one. This is probably worst case scenario, a negative on the inside, because it's going to reflect across this axis. And for some people, that's kind of weird to see. Although this one, honestly, it won't be a good example because we're not shifting horizontally. So sorry about that. But let's just go ahead and do it. This one, go find your HK. So that's 0, -4. Put a dot there. Now, if you think about it, the parent function, the original, looked like this, right? Well, it's going to reflect across this y-axis, meaning this section of line is going to switch over here and vice versa. If you don't shift horizontally, like we did not shift horizontally in this one, it's not really going to change anything. Because if I had a point right here, if it reflected across the y-axis, it would become here. And if I started with a point right here, if it reflected across the y-axis, it would go to this spot. So they kind of just switch spots, the left side and right side of this line. Again, this is not a good example for seeing this particular reflection. Sorry about that. But we'll go ahead and graph it. It's still going to be going up. It's only going to go down if you have that negative on the outside of those bars. So like this one's still going up, and it doesn't look any different. In terms of domain and range, the domain of this is still all reals. The range is from -4 to positive infinity. Maybe I'll do one more video where I show you some better examples of some reflections, because personally, these weren't the greatest examples. Sorry about that. And I didn't really name the transformations, all of them. I guess I could real quick. Over here, this was a vertical shift down 4. Over here, this was a horizontal shift left 2 and a vertical shift up 3. So I hope this video helped. I hope you did not get more confused from watching it. If you did, I apologize. The A over B part is very difficult to explain. But remember, if you get stuck, these are XY input-output machines. That's all they do. You input a number, they output a number all day long. So if you get stuck, like if I was stuck here, maybe take a point like an X value of 0, plug it in, get a value for it, 3/2, and just kind of check and see, is that at 1.5 right there? Yes, it is. Oh, okay, I must be doing it correctly. I must have the correct slope. You know what I mean? So hope this video helped, and good luck.